now we're going to talk about section 1.4, experimental design and ethics. Okay, so before we get going on starting up a design of a study, you want to make sure that your design of the study doesn't impact your data negatively. We want to make sure we have reliable and accurate data, and that only comes from proper study design. Okay, so we have, in an experiment, we have the relationship between two variables. We have the explanatory variable and our response variable. The explanatory variable is what we manipulate and change to see if we get a response in the response variable. So to see if we have any significant changes in the response variable. If you were thinking of it in terms of like an equation, you would say that this is your independent variable and that this is your dependent variable. But we don't call them that because we're not sure, because it's not like an equation. Okay, but that's just something that you can kind of tie it to. So the researcher manipulates the explanatory variable, and we measure this changes, and the difference in the values, in the different values of the explanatory variable are called treatments. And an experimental unit is a single object or individual that's going to be measured. Okay. Okay, so let's talk about lurking variables. Lurking variables can cloud a study. It's variables that we can't really see, that we can't isolate. We can do our best to try and isolate those variables, but they still might affect our data. So the way that we get around that is that we assign the people into different groups. So they're going to be assigned into the different groups randomly. That way the lurking variables get spread equally among all the different groups. Okay, so that's one of the ways that we are able to try and mitigate the effects of a lurking variable. So we want random assignment if at all possible. Now there are plenty of places where that cannot happen. Okay, and there are some examples in this text that'll help you see how sometimes you can't randomly assign to control for lurking variables. All right, so if we move on down, we have the two groups. You have the control group, and the control group is going to be receiving a placebo. A placebo is a treatment that cannot influence the response variable. It's not going to affect what you're trying to measure. Okay? The control group helps researchers to identify the effects of the treatment that they're testing. So you have your treatment group, which receives the treatment, and then you have your control group, which receives the placebo. Now, a placebo, our minds are amazing, and sometimes if we think we're taking something that's going to help us, our mind will make that help happen, even if that placebo didn't have anything in it. That's called the placebo effect. Okay? So we do something called blinding, which randomly assigns which people get assigned to the different groups. So which people get assigned to the active treatment and which ones get assigned to the control group who receive the placebo. Okay, so the people involved, if it's a blinding study, the people involved don't know if they're receiving a placebo or if they're receiving the treatment. Okay? But the gold standard in studies is called a double-blind experiment. This is when not only the subjects don't know which one they're getting, but the researchers who are involved also don't know which one they're giving. Because even the researchers, if they know what's happening, their attitudes, how they do things, could change and affect the data that is recovered. So once again, the double blind means that the subjects don't know which they've been assigned, and the researchers don't know which they've been assigned. And that's the gold standard. That's the best kind of study. All right, so let's take a look at example 1.19. Researchers want to investigate whether taking aspirin regularly reduces the risk of heart attack. 400 men between the ages of 50 and 84 are recruited as participants. The men are divided randomly into two groups. One group will take aspirin, the other will take a placebo. Each man takes the pill each day for 3 years, but he does not know whether or not he's getting aspirin or the placebo. At the end of the study, researchers count the number of men in each group who have had heart attacks. All right, so let's identify these values. Population, sample, experimental units, explanatory variable, response variable, and the treatments. So our population is all men between the ages of 50 and 84. So our population is all men between ages 50 and 84. Now, our sample, we can't test all men, but we were able to sample 400. So the sample is the 400 men within that age group that participated. The experimental units were the individual men themselves. Okay, so the people being observed in the study were the experimental units. The explanatory variable is the part that's being manipulated, the oral medication, the actual pill that they're taking. That's the explanatory variable. That's what we manipulate. That's what we change. And then the treatment is either going to be aspirin or a placebo. And our response variable is whether or not the subject had a heart attack. So that's what we're measuring. We are manipulating the oral medication with the treatment that's either aspirin or a placebo. And then we're looking at the response variable. We're looking to see if they had a heart attack, to see if taking aspirin actually had an effect on whether or not they suffered a heart attack. Okay, on the bottom of page 37, I love this. So there's wide misuse and misrepresentation of statistical information. So oftentimes, people will say numbers don't lie, but the people who present those numbers or have conducted these studies sometimes do, so that they can support whatever claim they're trying to have be true. So we need to make sure that we understand how studies are set up and how they should work, so that we can critically think about the studies that are put in front of us. So learning basic theory of statistics is going to empower you so that you can analyze statistical studies critically, so that you can look back and say, oh, that one was set up really well, that one makes sense. So that you can see if there was bias involved. Are there lurking variables? Did they do a double-blind study? Or was it only a blind study? So you can look back and think of it and say, okay, well, is the way that they're representing the numbers a fair representation of the data? Or are they trying to change how they represent the numbers to say what they want it to say? And that's the whole point of this. We want you to be able to look at the situation and understand what's being presented and decide if it's going to be valid or not.